All right, so again, I'm Mr. Johnston, and today we are going to be going over, today's September 16th, 2020. We'll be doing some less than, greater than, equal to involving irrational numbers. So today I can compare and order fractions, percents, decimals, and scientific notation, and show proficiency answering 70% of exit ticket questions. Remember that when we were talking about the real number system, we talked about irrational numbers. And we said that irrational numbers were things like fractions, decimals, percents. All of those kind of got lumped into the same category, irrational numbers. So just want to get Desmos opened real quick, because we'll be using that today. Let's see. We'll go down. All right, so before we even start, let's just review a couple of symbols, terms, all that good stuff. Pen going. Maybe the pen will be good to me today. All right, so we have this symbol, we have this symbol, and we have this symbol. Now, we've all seen these symbols before, so we know that this one stands for less than. We know that this one stands for greater than. And we know that this one, which I've already used now twice, stands for equal to. All right, so I don't know how you guys were taught to remember this, but I know that when I was just a wee lad 1,000 years ago, I learned it kind of like the alligator mouth, right? The alligator mouth was always open up to the bigger number because the alligator wanted to eat more. So that's one way. So you always know which way it's facing. The open side always goes to the bigger number. I had a teacher tell me this one, that this symbol right here kind of looks like an L, like you have an L, but maybe like somebody leaned on it and bent it over a little bit, right? So you've got that trick, just to help you kind of remember. Knowing that this is an L, because you're going to read it from left to right. So that's kind of important in math, is to be able to read these things correctly and know exactly like what this mathematical statement is saying. All right, so take a screenshot of this, save this. If you get confused, come back, pause that, review that. That's going to be pretty much what we're doing today. So we remember that if we have, before I even start, I'm going to tell you that I'm going to turn everything into a decimal. And the reason for that is because if I have a fraction, I have to turn a fraction to a decimal. If I have a percent, I can turn a percent into a decimal real quick, right? So I don't want to have to, if I turn everything into a percent, then I have to turn a fraction into a decimal, into a percent. So that's just extra steps. So in math, we like things to be as easy as possible, right? We don't want to have extra steps, because the more steps you have, the more opportunity you have for error. So we're not going to do that. So I'm going to show you real quick, just review from yesterday. We have the double dip method, correct? So we're going from percent to decimal. So we know that the decimal is going to move to the left, and we know that it's going to be 1, 2 to the left, and then the decimal goes there. We also remember that when we have a percent like this, that we can't see the decimal is always in front of the number, which would be to the right of it. In this, yeah, it's always in front of the number. So double dip, 1, 2. Decimal transplants there, add your 0. So what we have is 0.68. All right, I'm going to erase that. So now when I'm reading this, I'm going to go 0, 0, okay, decimal, decimal, it all lines up. Now I get to this 7 or 6, and then there's this 7. Now I know that 7 is greater than 6. I know that 7 is larger than 6, bigger than 6. It is greater than 6, right? So I'm going to use this symbol, the less than symbol, because the way that I read this is 68% is less than 0.70, right? This is saying that 0.7 is greater than 68%, but we read from left to right. So here we have another decimal already. Good, we don't have to worry about that. I'm going to come over here to 45%. I'm going to show you in Desmos. Now remember, if we have a percent, percents are always out of 100. It's just like when you get a score on a, This thing's gonna do this to me again today. It's just like when you get a score on a test or a quiz or something. It's always out of 100. You get 75 out of 100 or 99 out of 100. So we're going to do 45% divided by 100, which gives you 0.45. So that's going to be 0.45. If you do double dip method, you would know 1, 2, and you could see you get the same answer. So now we have 0.45. I'm going to draw a little 0 here in front of this 0.25, just that way these numbers have the same amount of numbers in them. Kind of like I'm like lining them up visually. It just makes it a little bit easier down the road when we get to some trickier ones. So I can see I have 0, 0, decimal, decimal, 4, 2. I know that 4 is larger than 2. 4 is going to be greater than 2. So now I read this as 45% is greater than 0.25. All right, again, double dip method, 1, 2, add that 0. All right, so I have 0.94. I'm going to add a 0 here at the end of this 0.1 because it doesn't really make a difference. It just makes it visually more appealing to me. You don't have to do this. I think it just makes it a little bit easier, again, when we get to trickier ones. So I have 0, 0, decimal, decimal, 1, and 9. I know that 9 is larger than 1. So what I'm going to do right here is that 0.1 is less than 94%. All right, again, 0.86, and we have 96%. So I'm going to do it on Desmos again. Remember, we have 96, whoops, whatever, 96% divided by 100. Remember, percents are always divided by 100, and you get 0.96. So I have 0.96. Now I'm going to go 0, 0, decimal, decimal, 8, and 9. And I know that 9 is larger than 8. So I'm going to write this out as 0.86 is less than 96%. So these are pretty much the exact same as the other ones. They're just percents and decimals. So I'm going to do 2 of these, and we'll move on just that way the video is not super long. So we have 42%. Again, Desmos, 42% divided by 100. And that is going to equal 0.42. So I have 0.42. So let me write it over here a little bit. I have 0.42. And then over here, I have 0.049. Now I'm going to add an extra 0 here just because I can. Again, it's just visually more appealing to me to have the same amount of numbers on both sides. So I'm going to go 0, 0, decimal, decimal. I have a 4 here and a 0 here. So I know that 4 is greater than 0. 4 is larger than 0. So I'll have 42% is greater than 0.049. Okay? So when I say like I like to add that extra 0, like if I don't have that extra 0 here, let me write that. You know, it'd be real easy to forget about this 0 and then start off with like 0, 0, 4, 4, 2, and 9. And then you would get the wrong answer because you would think that 9 is greater than 2 as you're working your way down. So that's why I like to add this 0 here. Also, by saying decimal, I know that seems a little redundant, but when I say 0, 0, decimal, decimal, I'm kind of checking myself off because I know that 0.420 aligns with 0.049. So I can do 0, checking them off, decimal, checking them off, and then I get to here, and that's where my issue is. All right, or that's where it's not an issue, it's where I get to solve the problem. Okay, last one for this, I'm gonna use the double dip method. Percent, 1, 2, to the left. Remember, always to the left if you're going from percent to decimal. Remember, percent to decimal. So I'm going to get 0.25. Here we can see 0.25 is in fact equal to 0.25. This one is a dead giveaway. Gives it already to you in decimals. I would just add that 0. You can see that the 0.2 is greater. And I realized I said that I was only going to do 2 of these, but I've made it this far. I'm going to go 1, 2, drop my decimal off. You have to remember to fill in empty spots with zeros. So what I end up with is 0.05. And again, add my 0 here. you can tell that 0.5 is greater than 0.05. All right, so now we've got fractions, decimals, percents, all sorts of good stuff going on here. So this is where I was saying Desmos is helpful. So I go 2 divided by 3, I'm going to get, oh, why it does that? 0.666666 over and over and over again, right? So I come back here, and I'm going to write in my 0.66666 with the bar over top, meaning that it's repeating, but I'm going to round it off at the hundredths. Remember, when we're rounding, this is my number, right? And I want to round it right here. I look over here. This number is greater than 5, larger than 5, so I add a 1 here, right? So then I get 0.67. And this is saying that this is less than 0.75. Now, if I'm not mistaken, this asks us what statement is not true. I cannot stress how important it is that you read the question. So we have 0.67, which is in fact less than 0.75. So this is a true statement, which is not what we're looking for. 40%, again on Desmos. Percents are divided by 100. 40 divided by 100, I get 0.4. And you'll start realizing that you can do a lot of this stuff in your head, okay? And we have 0.4 is greater than 0.1. This statement is in fact true, so it's not what we're looking for. We have 0.6 here, and that's gonna be less than a half. Like I said, you can do some of this in your head. And you can put a half in Desmos if you want, but I know that it's 0.5. It's half of 1. And here it says that 0.50 is greater than 0.60. So I think this is probably the false statement, the one that's not true. So I'm just gonna put a question mark there so I know I'm gonna come back and look at it because I wanna make sure that I do all of them. I always tell you, do all of them because you never know, you might make a mistake. I know I made one in third bell today, or block. All right, so I'm gonna start here, double dip, 1, 2, drop that decimal off right there, throw a 0 out in front. So what I end up with is 0.75 is equal to 0.75. And I can tell you that that is a true statement, which means that's not what we're looking for, which means that the correct answer is C. So you can see how we're using the same skill over and over again, but with different styles of questions. This is how they're going to get you. They're going to throw out some questions like this, throw out another type, and try and get you to like make a mistake. Remember I always say in class, the city's trying to trick you. They're the ones that send out the tests. All right, so now I've got 8 times 10 to the negative 1. So this is your scientific number. We remember that I will write it off to the side here. The most important part about this is this negative 1 right here, right? So I've got my number line, 0, 1, 2. That's all I'm going to go to today. So I know that it's negative, so that means I'm going to go this way down the number line. And it's got a 1 right there. So I'm going to move the decimal over 1 spot. My decimal is invisible because we didn't really need to write it, but now that we're using it, we have to. I move it over 1, drop that bad boy off, draw my 0, or write my 0. All right, so I get 0.8 is less than, and I don't know what 8 divided by 9 is off the top of my head, so I'm going to throw it in Desmos. And I get repeating 8. I guess I should have known what that was off the top of my head. So I have 0.88888888888 repeating, right? I'm going to round it off here right at the hundredths place. Let me rewrite all of that. 0.8. I'm going to round it to 9. So here's where I like to put in that 0, because if I don't have that here, I'm like 0, 0, decimal, decimal, 8, 8, 9. What's here? Oh, what's here? What's here? A 0's here. And we know that 9 is greater than 0. All right? So this one is a true statement. But we need to make sure we do all of these. Oops, sorry, I didn't mean to get rid of that. Again, I'm going to throw this guy in Desmos now, show you how to do, lost it, scientific numbers in Desmos. So we're going to put 2.1 times 10. I believe that was to the third, I believe, right here. Don't forget about your exponent to the third, and you get 2100. So here I have 2100. Another scientific number. All right. Put that guy in Desmos. I get 2 times 10 exponent to the 2. and I get 200. So that's 2100 is less than 200. I can tell you that 2100 certainly is not smaller than 200. All right, 87%. If we're doing the Desmos route, we get 87 divided by 100, 0.87. And I believe the other one was 8.7 times 10 exponent -2. Do not forget about your negative there, as you'll get a totally different number. So what I got here is 0.87 is equal to 0.087. And you can tell that that's not a true statement. And then I've got 0.14. That was nice of them to already do that for me. And 7 divided by 11. 7 divided by 11 gives me 0.63 repeating. Just to show you guys, that's 0.6363 repeating, right? But we're going to get rid of all of this afterwards, round it here, which will give you a 4. Because we had 0.6363. I look over here, that's greater, 5 or greater, so I add 1 to this. All right, and we can see that that's not true. All right, the last two are another type of question that trip people up. So we need to find a number that fits in here. So we have 0.4 is less than x, which is less than 75%. Okay, so first thing we need to do, everything's going to decimals. So I'm going to go 0.4. Remember, you can type this in Desmos because percent are always divided by 100. Or you can use the double dip method, 1, 2. Your decimal goes from here to here. Add that 0. So I know that that's going to be 0.75. Actually, you'll probably see a pattern when you have a basic percent like this, that it kind of just goes from 75% to 0.75, right? 30% will be 0. This one will be 0.30. And that's just because it works all the time. All right, so if you take 3/4 and you put that into the calculator, you get 0.75. Now here's a tricky one. Is 0.75 less than 0.75? Because that's what we want. We want a number that's greater than 0.4, but less than 0.5. And the answer is no. It is 0.5, so it can't be less than 0.5. All right, then we have 0.3. We can kind of throw this one away because we notice right away that it is less than 0.4. So it's not going to be greater than 0.4. That's what we're looking for. 219 divided by 250. I have no clue what that is. So I'm going to use my handy dandy calculator. And I get 0.876. 0.876. I can tell that it's 0.876 is certainly greater than this, 0.75. So it's not going to be able to fit in the middle. So now I can assume that this is my right answer, but we don't assume anything in math. We solve it. I've showed you how to do this on the calculator. Let's go ahead and do this one by hand. 10 to the -1. We look at this. We know that it's negative, so I'm moving the decimal that way. And it's got a 1. I'm moving it once. So I'm moving my decimal here, draw my 0, write my 0, and get rid of all this stuff, right? So I know that this is 0.61. And 0.61 is in fact greater than 4, and it is in fact less than 0.75. And the last one for the day is a number. We need to find a value of x that'll work for this, something that is greater than 0.5 and less than 54%. So I'm going to rewrite it again, 0.5. My x is greater than that, but less than, and we know that my decimal is going to be 0.54. Half is 0.5, as stated before. 0.5 cannot be greater than 0.5 because it is 0.5, so that guy's out. 35%, double dip, bam, drop it off, add the 0. I have 0.35. This is already less than 0.5, so we know that it's not going to fit here because it's not greater than that. And then we have 5.4, 10 to the 1. So we know that this is a positive, so decimal's moving to the right. It's 1, it's moving to the right once. So I move this guy over 1 time, and I end up with 54. And that doesn't even work for anything here. 54 is certainly greater than all of this. So you're gone. And 260 divided by 500. Hit the calculator up for that. and be irritated by that by 500, and you get 0.52. And I can see that 0.52. So now I'm going to go ahead and add me a little 0 in here just because these numbers are so close together, right? They're only being separated by 0.04, right? So we need to find, it's going to be a very tight fit for this number. So we have 0, good, decimal, decimal, 5, 5, 0, 2. We got 2 is greater than 0. So 0.52 is greater than 0.5. So it fits the first parameter. And it is less than 0.54 because we know that the 4 is greater than 2. So that works out. So D is our answer. Something I would just like to point out when we're doing problems like these is, let's say we have 1, x, and 5, right? So there's a bunch of numbers that'll fit in here. 2, 2.5, 4, 4.99. All right. Well, what this is kind of like two questions in one, really. I mean, this is one statement, but it can be, when you're reading it as 1 is less than x. And you're also reading it as x is less than 5. But you can combine them in the middle with the x. All right. So that's what we did today. There are more videos on Schoology going over the same material, just a different voice if you don't enjoy mine. And stop share. One day I'll get that right. I appreciate you guys watching. Have a good afternoon, and I will see you tomorrow for class. Thank you. Adios.